Hi guys! Today, we are going to solve a kinetics problem. Problem number 1. One solution contains A sub O is equal to 1.6 mole per cubic feet and the other B sub O which is equal to 1.0 mole per cubic feet. The reaction is A to B reversible. Equal amounts of solutions are mixed quickly and measurements of Ca versus time are made. Find the specific rates. This is the measurements of Ca versus time. So we are given with CaO, which is 1.6 mole per cubic feet, and CbO, which is 1.0 mole per cubic feet. And from the table, from this Ca versus time, we can see that after 5 seconds and to 10 seconds, the concentration of A no longer changes. So we can conclude that 0.520 is the concentration of A at its equilibrium. So we can now say that CAE is equal to 0.520. Now this problem is an example of a first order reversible reaction. Therefore, to solve for the specific rate of a reactant, we need first to derive the rate of reaction. We will start with writing the chemical reaction. A reversible B. So we will write negative Ra is equal to negative dCA over dt. And that would be equal to K1, which is the forward reaction, times Ca minus K2 for the reversed reaction times Cb. Now note that we can see in the chemical reaction that the stoichiometric ratio of A and B is 1:1. Therefore, we can express this Cb in terms of Ca. So we have Cb is equal to, put note here, Cb is equal to the concentration of Ca at its initial point plus concentration of B at its initial point divided by 2 minus Ca. So we can substitute this equation into here. So we have negative Ra is equal to K1 Ca minus K2 times Cb, which is this, CaO plus CbO all over 2 minus Ca. Now, why did we express B in terms of A? We did this because we are going to express the whole equation in just one variable, because the only given variable is A. So we need to express B in terms of A. Now, what we're going to do next is to express K2 in terms of K1, since we cannot solve two variables with using only one equation. So to express K2 in terms of K1, we will use Ke, which is the equilibrium constant. Ke, we all know that Ke is equal to K1 over K2. Therefore, K2 is equal to K1 over Ke. So, and then we can substitute this K2, value of K2 here. So we have negative Ra is equal to K1 Ca minus the value of K2 is K1 over Ke times CaO plus CBO over 2 minus CA. Now, we need to find the value of this KE. Now, we all know that, note that KE is also equal to CBE, the concentration of product B at equilibrium, divided by the concentration of reactant A at equilibrium. We have this right in the given, but we don't have this CBE. But since, as what I have said earlier, the stoichiometric ratio of A and B is just 1:1. Therefore, we can also relate its concentration at its equilibrium. So, we can have CBE is equal to CAO plus CBO divided by 2 minus the concentration of A at its equilibrium. So, we substitute the given. We have CAO, which is 1.6. So 1.6, and CBO, which is 1, plus 1 divided by 2 minus CAE, which is 0.520. 520. So we now get the value of CBE. So using our calculator, we have 1.6 plus 1 divided by 2 minus 0.520. The value of CBE is 0.78. So CBE is equal to 0.78. So we are now going to substitute this value of CBE in the KE. So KE is equal to CBE is 0.78, and our CAE is, from the given, CAE is 0.520. Therefore, solving for the KE, we have 0.78 divided by 0.520. We have 1.5. So we substitute this value of KE into our RA here. Therefore, so we have negative RA K1 concentration of A minus K1 over 1.5 CAO plus CBO 2 minus CA. So we are now left with one rate constant and one concentration. Therefore, we can now, since this CAO and CBO is just constant because these are the initial concentrations of A and B at their initial points at time equals 0. So since we now get this equation, we can now solve for the value of K1 using the given measurements of CA versus T. So we first simplify this equation. We have RA is equal to K1 CA minus K1, and we substitute the given for CAO and CBO. 1.5. CAO is 1.6. CBO is 1 divided by 2 C and CA. So we have negative RA equal to K1 CA minus K2 over 1.5, 1.6 plus 1 divided by 2. We have 1.3 minus CA, negative RA is equal to K1 CA minus K2 times 1.3 CA over 1.5. I mean K1. This is K1, guys. I'm so sorry. K1. So now going to simplify this further, we factor out K1. K1 CA minus 1.3 CA minus 1.5. So combining these terms, we have K1 1.5 CA minus 1.3 plus CA. So we have K1 times 2.5 CA minus 1.3 all over 1.5. Simplifying it further, we have negative RA K1 times 1.667 CA minus 0.867. So this is now our rate of reaction, or rate equation of our rate of reaction. So to further solve this, we need to find first K1. How to find K1? So we will use our given measurements of CA versus time. So we will graph it and we will use this equation. So we will express this in terms of T and CA. So we have negative RA negative dCA over dt is equal to K1 times 1.667 CA minus 0.867. So we have negative dCA over dt is equal to K1 1.667 CA minus 0.867. So we will transpose, we will combine like terms, we get K1 dt negative dCA all over 1.667 CA minus 0.867. Now integrating this from 0 from 0 to T, and this from 0 to 0.8, because 0.8 is our initial concentration of A, because we divide 1.6 with 2 to denote the initial concentration of A. So after differentiating that, we get ln 0.867 all over 1.667 CA K1 T. Now we graph this using our calculator with the x-axis of T and the ln 0.867 all over 1.667 of CA using our given, using this table. So from the graph, we get a slope is equal to 0.747, and this slope is actually equal to K1, because we all know that this is y is equal to mx plus b. This is the x and this is the y, and this is the slope K1. So we now get the value of K1, which is 0.747. So from this value of K1, we get the value of K2. We all know that Ke is equal to K1 over K2. And we have this value of Ke, which is 1.5 as we solved earlier. So we have K2, which is equal to K1 over Ke, which is 0.747 divided by 1.5. So we have K2, which is equal to 0.747 divided by 1.5. We have K2 is equal to 0.498. So now that we've solved for K1 and K2, we can now write the rate of reaction of reactant A. So negative Ra is equal to K1 Ca minus K2 Cb. Substituting the values of K1 and K2, we have K1, which is 0.747 Ca, and the value of K2, which is 0.498 Cb. So this is our rate of reaction, or rate equation of A. Thank you.